the circle has a center of O, okay, with a radius of P. So we have 0 to P to be the radius, because we know that any line drawn from the center of a circle to any part of the circumference is radius. That's why we have here to be radius. Now you can see that from P to our x-axis over here is being represented by y, because it corresponds with the y-axis. And here we have labeled it as x because it's on the x-axis over there. And this has created a line shape which has a right angle. And because of that, this shape becomes a right angle triangle. So from this right angle triangle, we have an angle theta sitting at this corner. And from this shape, you could see that we have sin theta to be cos opposite over hypotenuse, as it is nicely written. And we have cos theta to be adjacent over hypotenuse, which is x over r. Here too, we have tan theta to be opposite over adjacent. So from here, you can see anything, if we write anything as the statement goes, anything is divided by 1. So here sin theta is divided by 1, just that most we don't show them. And cos theta divided by 1, tan theta divided by 1. Okay, so when we turn these things upside down, when we turn them upside down, we are going to create a new ideas. So sin theta divided 1 out of sin theta. So when we reciprocate this, we are going to get 1 out of sin theta. Okay. So when we reciprocate this one too, we are going to get 1 out of cos theta. And this one, when we reciprocate tan, we are getting 1 out of tan theta. So remember, as we are reciprocating this side, the same applies to this section. So when we reciprocate 1 out of sin theta and 1, r and y also reciprocate. So we have r out of y. The same applies to this section, cos. We are having r out of x for our cos. Then tan, we have y out of x out of y. Okay. Now, whenever you write these things, when you reciprocate these basic ratios, they generate a new name, or we have a nice name for them. Okay? So 1 out of sin theta tends to be cosecant theta, which we shorten it to be cosec theta. Okay? So whenever you see cosec theta, then we are talking about 1 out of sin theta. And the reciprocation of cos, which is 1 out of cos theta, is also having a nice name as secant theta, which can be shortened as sec theta. And the same applies to tan. After a reciprocation of tan, we are getting a nice name for it, which is cotangent theta, and it can be shortened as cot theta, as you can see over there. Good. So back to the diagram. Okay, we have this shape has a nice, very nice theorem for it, which is the Pythagorean theorem, which we normally use to solve problems when it comes to right angle triangle, which says that hypotenuse squared should equal to opposite square plus adjacent square, right? So here you can see we have the variables for them, and therefore we can substitute them. We have hypotenuse is the radius, r squared. Opposite is the y squared plus adjacent our x squared. Okay, so this our new equation from this diagram. Now from here, let's try and divide through by our x. Let's divide through by x squared and see something. So after division, we have this. And here, in terms of indices, we can put them together. We have so over here, this one, cancel this one off, which will give us 1. Okay. Now here we have r out of x, all squared, y out of x. So can we see r out of x over at our identities or from our ratios? So r out of x, we can see it from the reciprocation of cos. Okay. So r out of x can be seen from the reciprocation of cos, which is 1 out of cos theta, which is given as r out of x. So this is r out of x. Then we have y out of x. Y out of x, where can we see our y out of x? So our y out of x can be seen from here. Tan theta is given as y out of x. Okay? So in place of these values, it means we can put in these ratios. Okay? So when we come here, we are going to have r out of x. R out of x over there is 1 out of cos theta, which is given as sec theta. So we have sec theta all squared equals, then we have y on x. Y on x over here we have tan theta all squared. And then we have our last item, which is plus 1. So we can put our plus 1 over here. Okay. Then we can expand the bracket to have sec squared theta equals, so we have sec squared theta equals tan squared theta plus 1. So this is the reason why we say that sec squared theta is equal to tan squared theta plus 1. Now from this identity, we can generate maybe 2 additional identities from here. We can also say that tan squared theta equals, by sending this one to this side, we'll be having sec squared theta minus 1. So we can say that tan squared theta equals sec squared theta minus 1. Or, better still, we can also say that sec squared theta, if we bring our tan squared theta here, we are going to have minus tan squared theta, okay, equals 1. So from this identity, we can generate additional ones, which is tan squared theta to equal sec squared theta minus 1. Sec squared theta to equal minus tan squared theta is given as 1, as you can see over here. And this is the reason why we always say that sec squared theta is equals tan squared theta plus 1, or tan squared theta equals sec squared theta minus 1, or sec squared theta minus tan squared theta equals 1.